If you're looking for the deadliest explosion in the universe, a supernova is a good place to start. A supernova can form an incredibly beautiful nebula, but the intense radiation emitted by these stellar explosions can sterilize entire planets. If a supernova were to occur near us, it could wipe out our entire civilization. But how far is near? New research suggests it's a lot farther than scientists previously believed. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. A previous study found that any supernova that went off within about 25 light years would be enough to wipe us out, but any farther than that and we'd be mostly safe. New research, however, increases that kill zone to 50 light years. The previous study left some effects out or didn't have good numbers, so now we think it may be a bit larger distance, says Adrian Malott, a researcher from the University of Kansas and one of the authors of the study. If you're feeling worried at this point, don't be. The closest star that could supernova is located more than 100 light years away and probably won't explode for millions of years. This new study doesn't increase our chances of dying in a radiation-fueled apocalypse, but it does provide an interesting look at the complex dynamics of supernovae. Cosmic rays like to travel along magnetic field lines, says Malott. If there's a magnetic field, it can either create a superhighway for cosmic rays, or it could block them. Depending on the orientation of the magnetic field around the supernova, it could either boost or block the radiation. A supernova combined with a boosting magnetic field could have a further reach than normal. But even with an ideal magnetic field, there are no stars anywhere close to us that could pose a risk. You're safe from deadly supernova radiation. Just don't think about gamma-ray bursts. New estimate puts the supernova kill zone within 50 light years of Earth. There are a lot of ways that life on Earth could come to an end. An asteroid strike, global climate catastrophe, or nuclear war are among them. But perhaps the most haunting would be death by supernova, because there's absolutely nothing we could do about it. We'd be sitting ducks. New research suggests that a supernova's kill zone is bigger than we thought, about 25 light years bigger, to be exact. Iron in the ocean. In 2016, researchers confirmed that Earth has been hit with the effects from multiple supernovae. The presence of iron-60 in the seabed confirms it. Iron-60 is an isotope of iron produced in supernova explosions, and it was found in fossilized bacteria in sediments on the ocean floor. Those iron-60 remnants suggest that two supernovae exploded near our solar system, one between 6.5 to 8.7 million years ago, and another as recently as 2 million years ago. Iron-60 is extremely rare here on Earth because it has a short half-life of 2.6 million years. Any of the iron-60 created at the time of Earth's formation would have decayed into something else by now. So when researchers found the iron-60 on the ocean floor, they reasoned that it must have another source, and that logical source is a supernova. This evidence was the smoking gun for the idea that Earth has been struck by supernovae. But the questions it begs are, what effect did that supernova have on life on Earth? And how far away do we have to be from a supernova to be safe? We can look for events in the history of the Earth that might be connected to them, supernova events. Dr. Adrian Malott, astrophysicist, University of Kansas. In a press release from the University of Kansas, astrophysicist Adrian Malott talked about recent research into supernovae and the effects they can have on Earth. This research essentially proves that certain events happened in the not-too-distant past, said Malott, a KU professor of physics and astronomy. They make it clear approximately when they happened and how far away they were. Knowing that, we can consider what the effect may have been with definite numbers. Then we can look for events in the history of the Earth that might be connected to them. Earlier work suggested that a supernova kill zone is about 25 to 30 light years. If a supernova exploded that close to Earth, it would trigger a mass extinction. Bye-bye humanity. But new work suggests that 25 light-years is an underestimation, and that a supernova 50 light-years away would be powerful enough to cause a mass extinction. Supernovae, a force driving evolution? But extinction is just one effect a supernova could have on Earth. Supernovae can have other effects, and they might not all be negative. It's possible that a supernova about 2.6 million years ago even drove human evolution. Our local research group is working on figuring out what the effects were likely to have been, Milot said. We really don't know. The events weren't close enough to cause a big mass extinction or severe effects, but not so far away that we can ignore them either. We're trying to decide if we should expect to have seen any effects on the ground on the Earth. Milot and his colleagues have written a new paper that focuses on the effects a supernova might have on Earth. In a new paper titled A Supernova at 50 PC, Effects on the Earth's Atmosphere and Biota, Milot and a team of researchers tried to shed light on Earth-supernova interactions. The local bubble. There are a number of variables that come into play when trying to determine the effects of a supernova, and one of them is the idea of the local bubble. The local bubble itself is the result of one or more supernova explosions that occurred as long as 20 million years ago. The local bubble is a 300 light-year diameter bubble of expanding gas in our arm of the Milky Way galaxy, where our solar system currently resides. We've been traveling through it for the last 5 to 10 million years. Inside this bubble, the magnetic field is weak and disordered. Milot's paper focused on the effects that a supernova about 2.6 million years ago would have on Earth in two instances, while both were within the local bubble, and while both were outside the local bubble. The disrupted magnetic field inside the local bubble can in essence magnify the effects a supernova can have on Earth. It can increase the cosmic rays that reach Earth by a factor of a few hundred. This can increase the ionization in the Earth's troposphere, which means that life on Earth would be hit with more radiation. Outside the local bubble, the magnetic field is more ordered, so the effect depends on the orientation of the magnetic field. The ordered magnetic field can either aim more radiation at Earth, or it could in a sense deflect it, much like our magnetosphere does now. Focusing on the Pleistocene. Milot's paper looks into the connection between the supernova and the global cooling that took place during the Pleistocene epoch about 2.6 million years ago. There was no mass extinction at that time, but there was an elevated extinction rate. According to the paper, it's possible that increased radiation from a supernova could have changed cloud formation, which would help explain a number of things that happened at the beginning of the Pleistocene. There was increased glaciation, increased species extinction, and Africa grew cooler and changed from predominantly forests to semi-arid grasslands. Cancer and mutation. As the paper concludes, it is difficult to know exactly what happened to Earth 2.6 million years ago when a supernova exploded in our vicinity. And it's difficult to pinpoint an exact distance at which life on Earth would be in trouble. But high levels of radiation from a supernova could increase the cancer rate, which could contribute to extinction. It could also increase the mutation rate, another contributor to extinction. At the highest levels modeled in this study, the radiation could even reach 1 kilometer deep into the ocean. There is no real record of increased cancer in the fossil record, so this study is hampered in that sense. But overall, it's a fascinating look at the possible interplay between cosmic events and how we and the rest of life on Earth evolved. Thanks for watching and see you on next video.
Yeah.